Okay, so it is 4 minutes after, five minutes after, is it? 4 minutes after, and we're going to start. We're going to start with survey, I'm sorry, bus elevations workflow. Here we are with Substation Design Suite. We're going to look at workflow of bus structures. I'm going to just take a look at my assembly here. And what you can see, I have two islands. I got an island on the left, and this has structures that are linked to the assembly as simplified parts. On the right side here, I have structures that are simplified parts with broken links to the assembly. So I have one side with linked, one side with broken links. What we're going to do is adjust the height of the structures and then see how we work with that. So I'm going to open up the structure. Here's the structure assembly, and I'll change the height. And I made it a little shorter, and I can save that. Now when I come back to my assembly on the left side, it can be updated. And you can see I need to update my bus and my cables. On the right side, it hasn't moved because those are broken links. So let's go back to the assembly. Well, I need to close this first. I'll save that. I'll go back to my assembly. Now I'm going to make a simplified part of this, and I'm going to break the link. So let's create a simplified part. I'm going to make sure I have the same style as my original simplified part was. And in this case, I chose the first one. It's not a big deal with the structures to pick this one. I would always pick this one if I'm using it for design checks, but in this case, it's not a concern. I'm going to save my file. I'm going to say it's going to be on the no link part, and I'll save that and say OK. And there's my item. It's no link, and I'm going to break that link now. And if you break the link, it works much better with Vault and managing Vault. So I can close this file. I don't need my assembly open for the structures anymore. Now I'll go back and I'll open up my assembly. I'll update it again. And now you can see everything's changed. I have a lower side here and a lower side here. There's no errors with my file because I saved it as a no link part with the same style. Key thing. Now I can come into my above grade tools. I'm going to update all cables just of my current assembly. And we'll update all my cables. And now I need to update my bus runs. A little different with the bus runs. When I update a bus run, it will open up the island. I'll hit enter to repeat command. Enter repeat command. There's my bus run. I'll save that. I want to open up the next bus run. Let's update. And let's update and repeat command. Update, repeat command. Update, repeat command. And we'll save this one. And close that. Update my assembly and save. So I've updated that in two ways. One with a link and one without the link. Okay, now that we've updated the bus height, we're going to change the foundations. In here we can see we have a longer foundation in here and a shorter foundation on this side. And typically what you want when you create an island, you want to include the foundations. It's easier to replace the foundation than it is to add a new one. So I'd always leave the foundation in here and I can replace that foundation. I'm going to find out where my island is, and that I know where this island is actually, and I'll expand it, and I'll pull out that specific assembly. I'll open up this assembly, and now all I'm going to do is replace the foundations. I'm going to collapse my browser so I can find them. And here's my foundations. I have 2 of them. I'm going to right click and I'll go to Component and Replace All. I have all my foundations, of course, in my Foundations folder. Come into 15 and I want to replace it with the 15 foundation. And it's easy as that. So now I have that assembly. And this is why I keep my foundations a separate assembly and I mate them to the WorkPoints. I can close this file now, update my model, and I have my new foundations in there as well now. So I want to talk about survey staking, and we'll have questions and answers at the end. I just want to get it through. So the survey staking is going to be about a 15-minute video. Here we are with Substation Design Suite. This is the webinar on survey staking. This is part 1, the LAN XML surface part. We're going to import this surface. Before we go any further, I want people to be aware that we have the import surface document on our website. Take a look at it, review it. There's also e-learning on this exercise that would be worthwhile to go through. So if you go in our e-learning, you will have that as well. So what I have here is assembly open. As a normal, our Substation Design Suite tools only show in assemblies. And we're going to come in and import a surface. I'm going to import it rather quickly. I expect users to be able to get into our training exercises to review it. So I'm going to bring in a LAN XML surface. And in this case, we're going to bring in the natural surface. We always need to bring in the surface. But down here at the bottom, we have some points to bring in. And the key points I want to bring in is some points that the Civil 3D people have added to it. And this is what I expect to happen, is people to communicate with their 3D Civil people to know reference points to bring into that land surface. So in this case, for reference point, I'm going to bring in the metal pins. We have several metal pins. If I expand this, you can see these metal pins. And I'm going to scroll down. I'm also going to bring in points. These are all going to be work points for the roadway. Edge of road. So I'm going to bring in the edge of road just for information. It's the pins that are going to be my pins for georeferencing. So I'm going to come in and I'm going to add it to my existing part, and I will import this. I'll select my existing part and it will import. So it took about 45 seconds to bring in this object. It was a little slower because of my training video. And I have my object in here. And you can see we have splines that we can do lofts on. I'm going to save this before I go further. And I'll open up the civil data item. And I'll save this again. Save and save often. So what we're going to do some lofts across here to create a surface. I'm going to come into my tools and create a loft. I'm just going to loft the surface. I'm going to select my splines coming across and I'm going to loft this up. And then I'll say OK. So I have my lofted splines. You can see the surface and you can also see the work points. The metal pins that I brought in are out here. And then I have all my edge of road pins. We don't need this many work points, but what we do want is a reference point for the orientation of our general arrangement and location of the general arrangement and location of the surface with respect to a reference point. And that reference point we're going to imagine is this pin here. And that's going to be our main reference point. So with this, I'm going to save it. The other thing I'm going to do, I want to be able to see this in my models when I go up further with this. So I'm going to take this loft, I'm going to right click, and I'm going to turn off its translucency. The other thing I'm going to do is I am going to change the properties of this. to a flake satin blue finish. So I'm just going to right click and come into properties and change it to flake satin blue, something like that. And there we have it, and I'll hit save. Now that I have my surface, I'll save it. I'm going to create a new assembly, and I'm going to place my surface in the new assembly as well as my general arrangement. I don't want my surface in my general arrangement. I can reference it elsewhere. It's just a method that I would recommend. Just keep things lighter and not heavy. So I'm going to create a file. You can name it whatever you need to name it, but I'm going to say surface with GA for this case. And I'm going to place my surface in here. So I have my surface, it moves around. I'm going to constrain it. The idea here is that metal pin is my georeference pin. It's out here, and this is what I'm going to mate to. I'm going to mate that to my origin plane. So I'll come up and constrain my metal surface reference point to the origin of my assembly. I'm going to keep the same orientation where it is in the elevation, so I'm going to ground this thing now. So let's ground it, and I'll say I am good like this. And save again. Now I can bring in my general arrangement. If you recall, we brought in some points. I'm going to constrain my general arrangement to 3 points in this area here. This is the roadway area coming down here, and my GA is going to sit in here. I'm going to bring in my general arrangement. The first thing I'm going to do is put a temporary constraint on that just for the origin XY plane. Just put a quickly flush constraint XY to XY just to kind of settle the item down before I fully constrain it. The other thing I'm going to do is rotate it to the general idea of how or where I want this item. Now I'm going to constrain the site skeleton, my fence edge, and this is the idea of these work points here are going to be the boundaries of my item here. So I'm going to bring in, these are those metal pins. And the other metal pin I'm going to bring in is the one up here in the corner. I'm going to the right side here. I'm going to put that to the metal pin up here. These are in the surface. All those pins are in the surface, and I'll save this. So what I've done, I've adjusted my depth of my GA that I placed here to account for how much reveal I want on my pad of the foundation. Normally, I would have a work plane on this that I could adjust and constrain to, but in this example, I did not put a work plane on there. What I want to do is get some points in here for the survey staking. You can see how my general arrangement is showing my foundation pillars, and it's also showing my pillars at my fence locations. So the next step now is to add the survey staking work. So now we're going to work with the survey staking. What we have in Substation Design Suite in our station design tools, we have an extract points tool. So I want to place points into my assembly such that I can extract these points. So the first thing I need to do is bring in a part to collect those points. So I'm creating a new part. I'll save this and I'll call it something to do with points. And I'll close this and I'll place this part into my GA assembly. and I'll ground and root it. I want everything ground and rooted so they all has the same reference. I want to change my level of detail of my general arrangement. I just want to see the reference of the foundations. I'll come into my civil points data, right click, I'll edit this feature. And what I'm going to do is add points in here. What I've done here to make it easy to add points on the top of all my foundations, I've placed a sketch point to easily attach my work points to. So I'll come up here, I'm going to select my points, and I'm going to easily select all my work points that I want to add. So I added one there, return. This makes it easy to have that sketch point visible to add these work points. One thing to keep in mind, they should be named so that you understand where these are. And we can do that in after the fact. So this is the fence corners. So I'm adding those work points. If I wanted to rename these, it's an easy way to rename it fast would be work point fence 1. I'll copy that and I'll bring it down to the next one. And this will be 2. And so on. Now that I've created those names, I'm going to update and save. I need to add further points. So I'm going to keep adding points. I have a work point for my foundations. And again, we're doing the same thing we did before. I have those sketch points available. It's a little bit tedious, but we could get all those points in there. If this is a popular thing, possibly we can build something more automatic in our software if this is something to be desired. Again, I should rename these items as well. So I'll rename them. Maybe this is work point F1. And we'll go through it in that way. Now I have all my points in there that I need. I am going to come back into my representations and change my general arrangement back to the previous, maybe the main, and I can save the overall. And save. So I have my work points all in this data, and now I can extract those work points. These work points are all going to be referenced to the 0, 0 value, which is our original point out here of our metal stake, our geo-reference point that we learned from the civil people. So I'll come into my Substation Design Tools. I'm going to extract my work points. I'll say in feet is okay. We can do it in different units. I'll say okay. I subtract my civil points data, and I can create this file. And here is all my work points referenced to that 0, 0. If we have this, we can convert these locations into coordinates for civil. We have our center point identified, 0, 0, and everything is off that center point of 0, 0. And we can do that work. I can now bring this into a drawing, and that's my next step. I'm going to bring in my general arrangement with the surface, and I want it quite small, so I'm going to make it the smallest I can right now. And I'll say OK to that. And I'll come into my surface, and we'll bring in that surface so that we can see it. Here's our surface. Bring it up here. And I can bring in our reference point. I can include that. There's our reference point up here. and I can do some dimensions or whatever else I may need for this exercise. So from here to maybe a point here, and I want that aligned, or maybe I want it a coordinate system, so I can bring in some dimensions and have that. This should also be my north-south orientation if the export from the civil is acceptable. And now I have this type of arrangement that I can work with. And we can bring in a data table. I'm going to bring in a general table. I'm going to import my XLX file. We can only bring in an XLS file. We can't bring in other files. So I converted my data to this file. I'll bring that in. And there's my data. So that's all referenced to 0, 0, which in turn is referenced to the geo-reference point that we got from our civil people. You can see the height change in elevation, which is the third unit here. And this table can be cleaned up, possibly have headers in it and whatever setup you want to do. But we have that information now available, and it's all referenced. All those points are referenced to that point, and we have the elevations to the top of the concrete. I want to bring up a website I was looking at, and I thought it was a, where is that website? World Coordinate website. And this is where I can really see work done. If I pick a point, like I have here, I got a place in Littleton, Colorado. That's where SBS offices are. It's very close to here. But you can see how we have over here, I have the latitude, longitude, but also have it with GPS, WGS coordinates, right? So we should be able to convert our locations in this manner. I think this is an excellent example of that to bring that in. So this is the this global positioning website, World Coordinate Converter website. So it's a really neat website that way. So I can bring that in. If we have those work points, and let's say we put those work points in our skeleton or create another file like our skeleton, we can bring those work points out of our skeleton as well. Or we can bring in another part like it did in that example and put my work points into this one as well. So if there's any questions, we can talk about it. If I came up here and did that tool here, I'll leave it as feet. I'll grab my webinar skeleton, and I'll just take it now as a test. And you'll see the work points that it brings in. You can see the work points because I got a work point at all 4 corners of my station, and I have a work point at one bus stand, and you can see the elevation changes. So if you look at the Z elevations, right? Oh, here. Z elevation is 3 feet here. It's about 2 feet negative. So this is positive, negative, negative 5 feet, negative 0.7, negative 0.28 feet. So you're wondering, well, why is it negative? It's because I am on a slope plane. So if you look here, I have a compound slope to this station that I'm working with. So this is going to be a future webinar working with compound slopes and working in this manner. But I think it was a good intro to get to that point, doing this webinar and moving into that next one about compound sloping. So I'll leave it open for questions, and we can answer those questions. I'm not seeing any, but we have time. So the went over it a little bit faster than what I thought it would with the videos. And I'd like to get feedback from you guys. If you're using it, if you're talking about it at work, give me an email and let me know how if it is working for you, what we can do to make it a little bit easier, you can email me here, of course, and just let me know what your thoughts are. That's really good to have as well. So I don't have any questions. I'll wait for a little bit. We can talk about Google Earth Pro can also convert coordinates. Excellent. Thanks, Holly. Okay, I have Nathan sent a question. Do you store information in the point file that you can use to help georeference all the other points in the file? Well, yeah, that point file is going to be available. So let's close this and open up the other survey statement. So here's my GA, and then I had that point file is in here. Surface with GA. So my point data is always going to be there. So I'll always have that available, right? So as long as I have these named, I can bring them in. I can bring in any point I want in here and bring that in. So I can edit this file. I hope I'm answering, Nathan. I have it open. Gotta close. I can't edit an open file. So if I want to add further points, I can certainly add further points, and I always have them in this file. Okay, Nathan says, I've used similar method on past projects to locate them. Excellent. That's good news to hear. Okay, Jeremy says, have a happy holidays, and thanks for the efforts here. That's great. Thank you, Jeremy. So are there any other comments that we need to address or answer? I think in the new year, I'm going to really focus on, okay, Nathan, I will see if I can give you audio. Nathan, I gave you
Hello?
Audio. I can hear you, Nathan.
Hi. Yeah, I just wanted to kind of elaborate on what I was trying to say. I'm not really the best at describing things with text. So I did use a method similar to this on a past project to georeference within Inventor. And the method that I ended up using, I had a point cloud or a point file similar to this, and then in the not the I properties, but in the functions, I created some user parameters for the origin point. Mm-hmm. So wherever it was located in space, say in Civil 3, you had the X, the Y, and the Z. I would create basically just a parameter that would say, you know, the X and the Y and the Z, just that information, what those point values were. And then you could use that in equations to drive the distances between the rest of the points in the file automatically. So you could get the actual real world spatial coordinates within the file. Okay. I don't know if I'm explaining that entirely
so
the best, but
you're applying a value to one point though, right? You're creating a value to that point.
Yep. So like the origin point, you'd say it's, you know, 104,357 X, you know, 89,555 Y, something like that. And then you have the Z, same thing. And then all the other points in that file, the way that I had set it up using equations, you could, wherever you had a new point, I would basically have an X, a Y, and a Z value for those as well in the as a user parameter, and then you would take, it was,
You do a
I believe it's,
calculation, right?
yep, basically like the x value minus the x value of your new point minus the x value of the origin, and it would give you the difference, the total difference from that point. It would automatically decide if it was negative or positive, so it would place it correctly.
So my thinking here is this table is in Excel. You could bring your data from your file and have this raw data here, and you could have another chart taking this data and converting it to your real world coordinates, right? By doing the math that you're talking about. Would that make sense?
Mm-hmm. Yep, and the only difference, basically, it's kind of similar to this, except it gave you the coordinates in Inventor instead of having to do an outside calculation.
Mm-hmm.
And I can show you that later if you'd like me to.
And then the key thing here was we have that tool that we can extract those work points directly, right?
Mm-hmm.
So that we were able to do that. Did you want to, you said you wanted to share your screen? I don't know if I can share screen.
No, I was saying if you wanted to talk about it later.
Yeah. I would like to see it, Nathan. I'll reach out to you maybe tomorrow or later this week.
Sounds good. Thank you.
That's excellent. I really like the feedback. Thank you, Nathan.
Yeah.
Ed, you had a question, break a link. So let's go back into that. I'm going to close this file. So what I was talking about with that is I'm going to go back to webinar bus elevations. So we have our assembly here. And if I open up a structure here, this structure here is a live link. So I'm going to open this up. So this is a live link, and I'm using simplified part to create this. So I'm going to open up the base one. We'll go through the steps a little bit here, but it is in the e-learning as well. I talk about this. But if we create a simplified part here, right, the simplified part tool is right here. And if that isn't viewable, if it isn't seen, we can come into Tools, Add-ins, and it's part of the BIM Simplify add-in. Sometimes people have that turned off because of whatever reasons. Once I simplify that part, I get into this assembly, and this one is an active link. So you can see that I have choices here, and I have the choice to break link with component. Now, typically, this is one way to see it, and then you have those live links. But my preference has been to do it in this manner, what I mentioned, breaking the link immediately, right? If I open this up, you can see how this one has a broken link. You can see this goofy symbol here. I don't know what it's supposed to be. It might be a chain with a red cross, or it might be an alien looking at us. But if I look at it, right-click, you can see I don't have that choice to break link, suppress link, or anything. I know that's a broken link. And that will never change with the assembly unless I replace the part. So if I come up here and go to Simplify Part again, I am going to, in this case, I'm going to select this one because that's what it was before. Originally, I want to make sure I'm always doing the same combined style. I can do multi-bodied, and that's typically what I would choose, especially for design checks. And then I'll save this, and I'll save it as a file with no link, right? Once I replace that file, I'm just going to make this for example name and go through it. I'll save it, say OK. Now it's called example, and I come up right here and I can break the link. And now it's broken. And you can, once you break the link, you can never go back. Same as other things in life. Okay, any other questions, concerns? Nathan and Holly, thanks for your input. Ed, thanks for your question. Okay, guys, we'll have a Merry Christmas, have a good holidays, and we'll talk to you in the new year, and we'll end it here. Thanks.